to fix this, we can just select rows where visits count equals 1. So we are going to remove this and actually make it where visits count equals visits counts equals 1. And we run that. Now our queries are getting much slower. So we have our records where the visits count equals just 1, and we have about 39,000 rows for that. So let's proceed. Okay, now that we verified that the table is joined correctly, we can remove the location ID and visits count columns. We can remove the location ID and visits count columns. So I just remove them, or I should comment them out. And location ID. But why is he? I've removed this. Why is he giving me error? I think commenting them out. I just commented them out. Alright. Add the location type column for location and time in queue from visit to our result set. So we're coming to add the location type column from the location, and then we will also add time in queue. So let's add.
Come on, please. I have a question.
Please ask.
The the two dashes you put there. Why did you put those there?
Yeah, actually, they asked us to, because their use was over the location ID and the visit count. We were using
Mm-hmm.
them to fill our table to see that everything was actually more than one visit. So now we don't need them anymore in our table. So I've just commented them out so that their column don't show in our table any longer.
So instead of deleting, we should do that. We will do it this way, right?
Oh, you can delete it. If you do it this way too, is okay. If you delete it too, it's fine.
Okay, all right. All right. Thank you.
Yeah, I just leave them inside for like following the procedure sake. Yeah, so I think we're working on location type. All right, location type. That's here from the location table, and visit what you're supposed to take something from the visits table to. Where is visits? Time in queue. Yeah, I remember time in queue. Okay. All right. So you have time in queue and location type. Let's proceed. So our table is looking good. Even though we've not aligned it exactly as this, it's still basically the same thing. Last one. Now we need to grab the results from the well pollution table. This one is a bit trickier. The well pollution table contained only data for well. If we just use join, we will do an inner join so that only records that are in well pollution and visit will be joined. We have to use a left join to join the results from well pollution table for well sources, and will be now for all the rest. Play around with the different join operations to make sure you understand why we use left join. Okay, so we are going to lift the well pollution table and then join them to the visits table. What in the well pollution table are we going to join? says the results, okay, results from the well pollution table. So let's go and play around the joints. Let's go and play around the joints. So well pollution dot results. Mm, and then let's go and join that somewhere here. Join well pollution at WP on WP dot results equals visit dot let's see what visit has. What does um well pollution and visit share in common? Okay, I think well pollution has source ID and visits has source ID as well. So we'll be joining them on the source ID. Okay, I think we are looking good here. All right, so here is the results, and let's. So the thing is that since we are using the join, it's performing an inner join, and performance of inner join means that it's going to retrieve only tables, only rows that they have in common, and in doing that, it's going to eliminate the rest of the rows that we still need. So doing a left join actually means that everything on the left table, that's our visit table, should be present whether or not it's present in the right table, in which case the right table is the well pollution. So let's do a left join and let's see everything that we have on. Let's see everything that we have on our table. Good. So we see now, we see the results. Some those that are in the visit table that are not in the well pollution table, we see they are nows. Yeah, that's exactly what we want. So let's go back. We've done our part on the joints. If anyone has a problem, please you can ask a question. So here is the code. This table assembles data from different tables into one simplified analysis. So select water source, water source type, town name, province, location. I mean, what we just did. Yeah, yeah, that's what has just been done. I should have just come and copy and paste this one to save ourselves some time. But anyway, let's proceed. So this table contains the data we need for this analysis. We want to analyze the data in the results set. We can either create a CTE and then query it, or in my case, I will make it a view so it's easier to share with you. I'll call it combined analysis table. So let me copy this. For me, I like creating the view because it simplifies my life. The CTE is more of a hassle. So create view. This is the name of the so we come last hour and then close our brackets. We first have to clean this and replace it here. Now our view, let's run our view. Good. So now our view is being created. We can test that by selecting everything from combine analysis and see. I've forgotten my from. Wow. So as simple as that. So our view is done, and then we can query from it anytime, any day. All right. Here is it. Blah blah blah. We've already done that. This view creates a table that pulls information from different tables into one. You may notice our query is starting to slow down because it involves a lot of steps and runs on 6,000 rows of data. Let's see if you are actually having 6,000 rows of data. Okay, here you might not see your 6,000 rows of data because we've set our data, our visit count to just one. But if we should, let me just comment it out. Those of you who were wondering, because someone approached me with this, those of you who were wondering, okay, so this is, let's run it from this, rather. Oh, no. Okay, and then let me show you guys one critical thing. If you've already created a view and then you need to edit that view, remember that when you edit that view, it won't work unless let's say you've updated it, but then you are still running your query and then you're not getting the update that you've made. A simple trick to deal with that is to use this function create. You see, I removed the visit count, I commented it out, but we are still getting 39,000 rows instead of about 6k 60,000 rows. So it means that that view has been has not been updated. So you use create or replace view to make an update, or to yeah, to make an update. So let's see the changes that is going to that. So now the changes have taken place. Let's go and run this query again and see. Wow, 60,000 rows is a lot. So we see the trick here. Now it has worked. It is now working. So the visits counts, it was because we set it to one. That's why we're seeing that 39,000 something row there. So let's rerun this query again. As I've edited it, let's see if we get by our 39,000 rows. All right, so you're on point. Let's move on. The last analysis, we are building another pivot table. This time we want to break down our data into provinces or towns and source types. If we understand where the problems are and what we need to improve at those locations, we can make an informed decisions on where to send our repair teams. We did most of this before, so I'll give you the queries I used, explain them a bit, and then we'll look at the results. The queries I'm sharing with you today are not formatted well because I'm trying to fit them into my chat messages. But make sure you add comments and document your code well so you can use it again. All right. So this is the pivot table code that they've given us. We are going to group our data by this the province names, the water type, I mean, they are grouping them into province and towns and source types. So you see them here. So we won't do much. We will copy everything. We won't stress ourselves. But the most important thing is you have to understand how these queries work so that you can write them on your own. But for time's sake, you copy, go and paste them, and then edit them to match the tables in our. So it starts from here. So this table is going to be called province total. So they've made it in a CTE with the province totals as. And what's this table containing? It has the province name, and then they are summing up the people served. But we know that in our our database, we have it as number of people served. Let's quickly check that out because this thing can really mess up your whole code and then you'll be brainstorming for days. Number of people served. Where do we see that? Where do we see that? We see that in number of people served. Is it water source? Yeah, water source. Yeah. So number of people served. We see it here. Good. Yeah. So number of people served, and that's they've named it as total people served from combined analysis table, the table that we just created. Okay. All right. So then it's being grouped by province table, and then now they select CT. They select the province table from the combined analysis table. Let's make sure to decode to do this well before we proceed. So from combined analysis table, mhm, city province name. Okay. From all of this, it says the case statements create columns for each type of source. The results are aggregated and percentages are calculated. So when you look into this very well, it says case when source type is equal to river, then people served. So when it sees where source type is equal to river, then it should produce what? The number of people served. So let's quickly just copy this whole code. Anywhere we see people served. So it should produce the number of people served, or it should give us 0. And then you should multiply the whole thing by 100 divided by the percentage total of the people served. All right. As river, that's for the river column. Putting the river here will give the column name. So guys, remember. And this one too is source water type. So it's the same thing. But what we have to do is change wherever we see this and place it with this. Here also replace it. Place this one. I think yeah, and then last one here. Cool. So now the source type. So we know that's not the name. We have to look for the name. Water source. Yeah, water source. Copy and then place this. Place this. Place this. And then I think this one as well. Place it. All right, cool. So we are selecting all from the combined data analysis table named as CT. Cool. And we are joining them on province totals as PT on city province name. The yeah, I guess by now you understand this code. So we are grouping it by the province name and we order it by province name. Okay, so let's run this quickly. Unknown column, source type. We have source type somewhere hidden. Source type. Got you. Again, where else? Water source, water source, water source, water source, water source, water source,
Mauli,
water
there's
source.
there's no column called water source. Water source is the name of the table, so it's type of water source.
Type of water source. Oh, Yehovah. All right. Let me let me just copy it from here. Where's type of water source? Yeah. Okay. Is this? when water source type of this whole thing is wrong. Type of water source is here, is here, and is here as well. What else? What else? So type of water source, type of water source, type of water source, type of water source, type of water source. Let's run this in. All right. So our query is on roots, and then what a wow. Hmm. Nice. So let's hop on the slide and see if you're on track. So province totals is a CT that calculates the sum of all the people surveyed group by province. If you replace the query above with this one, select everything from province total, it should get a table of province names summed up populations for each province. So just like we are seeing here, grouped into province names, and then everything has been summed up. So you should get a table of province names and summed up populations. Summed up populations. What is the summed up populations? Populations for each province. Okay, okay, all right. The main query selects the province names, and then like we did last time, we create a bunch of columns for each type of water source with case statements. Each sum sum each of them together and calculate percentages. We join the province totals table to our combined analysis table so that the correct value for each province PT total served people served value is used. Finally, we group by province name to get provincial percentages. Run the query and see if you can spot any of the following patterns. Look at the river column. Sokoto has the largest population of people drinking river water. We should send our drilling equipment to Sokoto first so people can drink safe filtered water from a well. The majority of water from Amanzi comes from taps, but I think we should run our query first before. Um, so let's intentionally select everything from province totals and see. Province totals. This isn't going to run. Yeah, because this is a CTE and we can't query it again once we've done that. Let me just create a view so that okay. All right. Create view province totals. You have an error. Hmm. The city should end here. Should end here, not here. All right. So we can even still run this from its. Let's run everything from province total. It's basically going to give you so we see the summed up total number of people served. Like cool. So let's go and run it. Let's go in. They said the main query select the province names, and then like we did last time, we create a bunch of columns for each type of water source with case statements, sum each of them together and calculate percentages. We join the province totals table to our combined analysis table so that the correct value for each province percentage total number of people served value is used. Finally, we group by province name to get the provincial percentages. Let's break this down. It says when we run this, we should get total province names and sum up population of each province, which we already have. The main query selects province names, and like we did the last time, we create a bunch of columns for each of water source with case statements, sum each of them together and calculate percentages. So we join the province total table to our combined analysis table so that the correct value for each province percentage total value is used. So now we are going to join our uh, province total province totals to the combined analysis. And then what do they have in common? They have province name in common, and then they have I think province name in common. So how do you do that now?
Sammy,
Let's
isn't that
figure
what
out.
you just
Yeah.
worked on right now?
Is that?
Isn't that what you just worked on right now before creating the view for the province totals?
Hmm. Okay. Okay. It was joined here. Yeah. See, that's why I was even thinking about it because I've forgotten already. So I don't think we have much to do here anymore. We can proceed, right? Or finally group them. Yeah. So I think that's yeah. Good. Thanks very much, Richie. So run the query and see if you can spot any of the following patterns. Look at the river, Sokoto. So when we run this, we can. They say Sokoto has the largest population of people drinking river water. Good. And the majority of water from Amanzi come from taps. So let's go and see that. So here is Sokoto. River has 21. Shared taps have 38. Yeah, and then the rest. So shared tap, they are working, so that's cool. But aside that, 21% of the people take water from river. And Amanzi too, it says Amanzi people's water come from where? Come from taps. Okay. Amanzi to yeah, share taps and tap in home. Right. And basically that's it. Fixing a large pump. That's that. I made another graph to help us see patterns. So I
Sammy, I
mean we can
think
go through.
someone has a question. His hand is raised.
Okay, please, if you have a question, just go ahead and ask. I'm currently not on the Zoom platform, so I won't see your hand raised. So just
Oh,
unmute and
okay,
ask.
sure. So I wanted to find out which query did you create a view for to find the total number of province?
So this query was given to us as a CTE. As a CTE. Here is it. This one, the province totals. We calculated the province and summed the number of people that were being served, and then it's named that as this. But because it was given as a CTE, we just wanted to test this query to see if it will work. And as a CTE, we can't test it like this. So I just made it into a view so that we can query it like this and see if it will work. So it's just a CTE. We can maintain it as a CTE, but making it a view to test our theory is the reason why I made it a view. So it's actually not a problem. You can leave it as a CTE. You don't have to convert it to do this. Are you okay?
Oh, yes, please, I am.
Let's aggregate the data per town now. You might think this is simple, but one little town makes this hard. Recall that there are two towns in Maji Ndongo called Harare. One is in Akachi and one is in Kilimani. Amina is another example. So when we just aggregate by town, SQL doesn't distinguish between the different Hararis. So it combines their result. To get around that, we have to group by province first, then by town, so that the duplicate towns are distinct because they are in different towns. Here is the query. So it's talking about, so since there are two Harare towns, we have grouped the province name and town. So just the first query, but then now they've grouped it by province name and town name. So actually, we can copy this part of it, because I think that's the only difference. That's the only difference. Let me copy this whole thing and paste it. We have basically the same syntaxes, just the grouping that made a difference. So in order to run it well, you have to switch. I think switching this will be a whole lot of problem. Let's just go by the grouping. Uh, we grew by we grew by province first, then town first. On a second thought, I think we should just edit it. I don't want to tamper with that other one. Number of people served. Copy. And then yeah. Then we work on the source type of water source as well. Do this. Start from here. Okay, last one here. I think we are good to go. So they group this one by the province first name and then by town. We realize that they made a comment here, but if you don't copy and re-comment it well, you have issues. So, and then here too, you see these are all comments, but because the code we copied was not actually accurate. So it says since the town names are not unique, we have to join on a composite key. And that composite key is the town totals TT on the CT province table should be equal to the TT province name, and CT town equals TT town name. So composite keys, two keys, a primary and a foreign key makes up a composite key. So that's what we are seeing here. Province name and town name should be equal to this town name. All right. So let's do all to check for that. Let's check if there are any other comments in that were not well commented out before we run our query. So this one like this, all right, and then here, and they say that two are towns, you have to group by province name and town name. That's fine. So command analysis group by province name, town name, select everything. I think we are looking good. We are looking good. Let's run this and see. Error code. People served. So we missed. Apparently, we missed one of the number of people served. Where could you be? Where are you? Okay, here. So let me copy it from here. Paste it here. Let me do that again. Okay, our query is in good shape now. Mhm. So now we've grouped them province name and then town name. Then we are seeing the type of water sources. Okay, that's cool. So let's move on. Here the CTE calculates the town totals, which returns three columns: province name, town name, and total people served. Is that what we are getting? I'm not getting total people served though. Why? Sum. You are supposed to sum this as total people served, but it's not inside our code. Town name, total people served. Here he brought it here, but here he didn't ask to see the number of people served. He summed it here nicely, but here he didn't bring it here. That's why. So if we should add the this total people served in this query, I think we'll be seeing that. Let's copy and paste that here. Well, the query is taking very well.
Question, please.
All right.
So you're writing the select total people served. As you shorten it, does it still is it okay? Does it work? Or if
Yes.
the table
So is
itself
that
is served in full, if we type it in like shorthand, would it work?
mm, yeah, it
Uh,
will work because this is the sum of the number of people served, and then we aliased it as the total people served. So it will we can either copy this code here and paste it, or we can copy the alias that we gave it and then paste it, just like we are seeing right here. So it will work.
right, okay. I
When you
got that.
yeah, when you yeah.
Thanks.
So Chidi confused us small, but at least we've maneuvered our way through. All right. So in the main query, we select the province name and the town name and then calculate the percentage of people using each source type using the case statement. Then we join totals to combine tables. But this time the town names are not unique. So we have to join town totals. But we check that both province name and town name matches the values in combined analysis table. Then we group it by province name, then town name. This query can take a while to calculate. So hopefully you start to see how a query can quickly become slow as it becomes more complex. We are witnesses of that. This query can take a while to calculate. So hopefully start uh, tautology. Before we jump into the data, let's store it as a temporary table first. so it is quicker to access. All right. Temporary tables in SQL are a nice way to store the results of complex query. We run the query once and the results are stored as a table. The catch, if you close the database connection, it deletes the table. So you have to run it again each time you start working in MySQL. The benefit is that we can use the table to do more calculations without running the whole query each time. We've heard that to do it, we add this to the start of the query. So create temporary table, aggregate, yeah, town aggregated water access. So we go and paste this directly on top of our CTE to make it all right. Here, let's paste it here. Yeah. So let's run this. So create temporary table, town aggregated water assets. As simple as creating a view or a city. Okay, so we have total 31 rows affected, no duplicates. Okay, so our table is ready. Now let's see it. And this will be the results. So let's go and check. That was what we saw earlier. So I mean, if you are rerunning the table, we are just making the query take a long time. So let's order the results set by each column. If we order river this by descending order, it confirms what we saw on the provincial level. People are drinking river water. So let's see. Let's the river. You have to run this again. Let's select everything from total aggregated table. What's the name? What's the name there? I think I copied something earlier. So I'll just clean all of this. Let's run this. All right. I think we should just go and delete that total number of people served. Let's leave it for the meantime. So the river, clicking on it will first make it in ascending order. Clicking on it again will make it descending order. So that's an easy way to do that. You don't have to necessarily order it again. Just clicking on it. So we see Sokoto, they are drinking river. So just like Chidi Kuntu said. Mhm. But look at the tap in home percentage in Sokoto too. Some of our citizens are forced to drink unsafe water from a river, while a lot of people have running water in their homes in Sokoto. Large disparities in water access like this often show that the wealth distribution in Sokoto is very unequal. We should mention this in our report. We should also send our drilling teams to Sokoto first to drill some wells for the people who are drinking river water, specifically the rural parts and the city of Bahari. Next, sort the data by province name. N- Sort the data by province name next and look at the data from Amina and Amanzi. Here, only 3% of Amina's, so we are going to sort by province. Here, only 3% of Amina's citizens have access to running tap water in their homes. More than half of the people in Amina have taps installed in their homes, but they are not working. We should send our teams to go and fix the infrastructure in Amina first. Fixing taps in people's homes means those people don't have to queue for water anymore. So the queues in Amina will also get shorter. So it says when we sort by province name, and so that we bring Amina first. We see Akachi. Let's go down a little to Amina. town name. Where is Amina? Amanzi. Amanzi. I'm not seeing Amina here. Why? Province name Anna. But look at the tap in home. Hey, sort the data province name next. And look at the data for Amina. But why am I not seeing Amina inside?
Amina is actually a town name, so check it.
Aha, okay, alright, here it is. So yeah. So okay, Amina is here. Amina is here. Alright, thanks. Some things you can't forget. Some now have 3% of citizens having access to running tap. We see the 3%, the tap in home. 3% spill. Imagine logo is suffering. There are still many gems hidden in this table. For example, which towns which town has the highest ratio of people who have taps but have no running water? Running this, select province name, town name, and then round tap in broken home. Tap in home broken divided by tap in home broken by tap in home times 100 as percentage broken taps from so and so. Let's do this quickly and let's see what we get. Replace that. Mhm. So province name, town name, and then this, and that's search on this. So after running, what are we to look for? We we can see that Amina has infrastructure installed, but almost none of it is working, and only the capital city, the harbour's water infrastructure works. Strangely enough, all of the politicians of the past governments lived in the harbour, so they made sure they had water. The point is, look how simple our query is now. It's like we are back at the beginning of our journey. So let's see Amina. So Amina have 90%, 95% of broken taps. And then let's look at the Habu. The Habu only has 2% of broken taps. So the politicians, they are making their time there nice. It would be so nice to see this data, right? But because there are so many sources and so many towns, it's hard to explain this visually without some better tools. Imagine we could have a graph where we do this kind of filtering and sorting of data in the graph. Well, you will meet Delilah soon and she will help us to build something like that. Summary report. Insights. Okay, so let's run some of the data we have. A couple of weeks ago, we found some interesting insights. Most water sources in a rural Most water sources are rural in Margin Logo. 43% of our people are using shared taps. 2,000 people often share one tap. That's ridiculous. 31% of our population has water infrastructure in their homes, but within that group, 45% face non-functional systems due to issues with pipes, pumps, and reservoirs. Towns like Amina, the rural part of Amanzi, and a couple of towns across Akachi and Hawassa have broken infrastructure. My hometown, and then they are mentioning it like that, Akachi. 18% of our people are using wells, of which, but within that, only 25% are clean. These are mostly in Hawassa, Kilimani, and Akachi. Our citizens often face long wait times for water, averaging more than 120 minutes. Queues are very long on Saturdays, queues are longer in the mornings and evenings. Wednesdays and Sundays have the shortest queues. Plan of action. We want to focus our efforts on improving the water sources that affect the most people. Most people will benefit if we improve the shared taps first. Wells are a good source of water, but many are contaminated. Fixing this will benefit a lot of people. Fixing existing infrastructure will help many people. If we have running water again, they won't have to queue, thereby shortening queue times for others. So we can solve two problems at once, killing two birds with one stone. Installing taps in homes will stretch our resources too thin. So for now, if the queue times are low, we won't improve that source. Most water sources are in rural areas. We need to ensure our teams know this, as this means they will have to make these repairs or upgrades in rural areas where road conditions, supplies, and labor are harder challenges to overcome. Practical solutions. Communities are using rivers. We will dispatch trucks to those regions to provide water temporarily in the short term, while we send out crews to drill for wells, providing a more permanent solution. Sokoto is the first province we will target. If communities are using wells, we will install filters to purify the water. For chemically polluted wells, we can install reverse osmosis, that's RO filters. And for wells with biological contamination, we can install UV filters that kill microorganisms. But we should install RO filters too. In the long term, we must figure out why these sources are polluted. For shared taps, in the short term, we can send additional water tankers to the busiest taps. On the busiest days, we can use the queue time pivot table we made to send tankers at the busiest times. Meanwhile, we can start the work on installing extra taps where they are needed according to UN standards. The maximum acceptable wait time for water is 30 minutes. With this in mind, our aim is to install taps to get queue times below 30 minutes. Towns like Bello, Abidjan, and Zurich have a lot of people using shared taps, so we will send out teams to those towns first. Shared taps with shorter queue times, less than 30 minutes, represent a logistical challenge to further reducing waiting times. The most effective solution installing taps in homes is resource intensive and better suited as a long-term goal. Addressing broken infrastructure offers a significant impact even with just a single intervention. It is expensive to fix, but so many people can benefit from repairing one facility. For example, fixing a reservoir or pipe that multiple taps are connected to. We identify towns like Kamina, Lusaka, Zuri, Jenny, and rural parts of Amandi seem to be good places to start. Practical plan. Please, someone should help me with the reading. Amir.
Our final goal is to implement our plan in the database. We have a plan to improve the water sources in Imagine Dogo, so we need to think it through. And as our final task, create a table where our teams have the information they need to fix, upgrade, and repair water sources. They will need the addresses of the places they should visit, street address, town, and province, the type of water source they should improve, and what should be done to improve it. We should also we should also make space for them to sorry, we should also make space for them in the database to update us on their progress. We need to know if the repair is complete and the date it was completed, and give them space to upgrade the resources. Let's call this table project progress.
Thanks. So now the whole statement was that we are coming to create a new table for them so that they know the engineers know, so that they know where to go, what to do, and we can track whether they are progressing or not. So this query is simply creating a new table that we are going to insert in our database. So let's quickly copy and paste this in our workbench. I really love this project because copy and paste need doors. Don't don't be writing plenty things. So copy and now paste. So let's do our code and see. So we are creating a table. Let me end this here. Okay. So we are creating table just like we know back to basics. Create table and then our table name project process. Then you see process project progress. We open our tab. Then we put in our column names and then the we I mean the data type. So let's see what we have here. We have our project ID and then it's set to serial and then it's our primary key. It says project ID unique key for sources in case we visit the same source more than once in the future. Okay. But the serial, I don't really know what the serial is. If someone knows, please the person can shed more light on that. I'll look at that later. Source ID is Varka 20, not now references. Not now, and it should reference the water source ID. And on delete cascade, on update cascade. These people, what they taught us, they are bringing things that we've not even seen before. This thing, the on delete cascade, on updates, see, I don't even know. And then address, voucher. Why is this error here? Wiki.
I mean, is the comment after the address?
It's a comment after the address. Aha, good, thanks. So you have to clean this and then comment it well. Yeah, thanks very much. So address is voucher 50, town to voucher 30, province name voucher 30, source type. Yeah, I mean improvements voucher 30. So let's fix this comment as well. Good. Then source status down to voucher 50. And then we have here default backlog. Check source status in backlog in progress incomplete. This is actually checking, it's checking source status. This code here, I really have to find time and then see what it means. But yeah, a quick way to do that is just copy and paste it in ChatGPT and then to explain what all of these things does. I haven't gotten the time to do that yet, but I'll do that later. So that you understand what all these things are. Apparently, they've not taught me, but we can learn from that. And then dates of completion. So these are the columns we are going to see in our data, in our table, in our new table. You have to comment these ones out as well. Engineers will add this to the data has been updated. Comment text. And so comments and text are. So let's just run this. Table. Okay, all right, guys. So this I've already created this table. Unless okay, let me drop if it exists.
I mean, just make a copy of it. Maybe it will affect the one you've already worked in.
Okay,
So you
so
can
I
make
should
this
do
copy.
this one.
Copy.
Copy. All right, thanks for that idea. It was very sharp. Yes, so now we've created our table. I don't know what I'll do without your chat. God, saving my ass all the time. So here is a less commented one. So it is easier to see how we design the project process table. So it's just the same thing, just that they've explained, the other one they've explained too much things. And this one looks neater and clearer. But we are done. So run this query and we are going to build the query we need to add the data in there. Good. At a river high level, at a high level, the improvements are as follows. Rivers equals drill well. wells, meaning where we see rivers, we are going to drill wells. Wells, if the well is contaminated with chemicals, then we are going to install an RO filter. And then wells, if the well is contaminated with biological contaminants, then we are going to install a UV and RO filter. Then for shared taps, if the queue is longer than 30 minutes or 30 minutes and above, then we install X taps nearby where X number of taps is calculated using X equals floor time in queue by 30. Tap in home broken. Diagnose a local infrastructure. So let's keep this in mind. Can you see that for wells and shared taps, we have some if logic? So we should be thinking case functions. Let's take the various improvements. Let's take the various improvements one by one, then combine them into one query at the end. All right. So all this, remember the new table that we create, we are going to add an improvements column there. So when we see the rivers, we will have to drill wells. For the wells, if they are contaminated with chemicals, we have to put there that install. This has to make it the job of the engineers easy, so as they know what and what to, I mean, do just at a glance of the table. So to make this simpler, we can start with this query. So we are selecting the address, the town name, the province name, the source ID, the type of water source, and results from the project progress query from water source. Then we join the world pollution. I think we already have this. We already have this. We already have this query somewhere in what we did. So let's quickly check if they are still there. Yeah, I think that was the first query we created. Yeah. So no, but there's actually a difference here. Here they all were selected from the water source. They were all selected from the water source. But aside that, everything else is different here. So let me just copy this. Please, if anyone doesn't understand something, let me know why we are doing something and why we are not doing something. Let me run this. So now what we are doing now is that we are trying to build columns that we are actually going to populate the project progress table with. So we build everything, see how it looks like before we fix it into the project progress table. So that's what we are trying to do now. And yes, now we have a query containing address, a town name, a province name, a source ID, and a type of water source, and then the result of the water pollution. We are copying all of this from the water source, joining it on the water pollution, joining it on the visits, and then the location. Cool. Yeah, that has been explained further. First things first, recipe sucker fail. Let's filter the data to only contain sources we want to improve by thinking through the logic first. Only records with visit count equals 1 are allowed. Any of the following rules can be included. A. Where shared tabs have queue times over 30 minutes and only wells that are contaminated are allowed. So we exclude all wells that are clean. And let's include any river and tap in home broken. Let's include any river and tap in home broken sources. Okay, so we'll be doing this in a minute. So it says what? we are going to filter our data, meaning we need some where clauses in there, and then set records where visit count equals one, only one. Okay, let's jump on there. So where visits visits dots visits equals one, and then any of the following rows can be included. It means we can add any that we want. Or to be safer to add all, where shared tabs have a queue times over 30 minutes. So time in queue, where shared tab is in water source, right? So water source, water source dot um no, where type of, yeah, sorry, okay, water source dot type of water source. At least you have to specify which table we are coming from, equals shared tab. Hey, is it actually shared tab? Let me view that real quick. So we have shared tab. Okay, so that's cool. Shared tab. Shared tab. And shared tabs have queue times over 30 minutes. So, and time in queue. Time in queue is actually in the visit table if I'm not lying. Yeah, so let's clean this. This one, yeah. Dots time in queue is greater or equal to 30. Where is error coming from? Shared tab has to be in quotations. Okay, so let me put everything in brackets. See if that solves our problem. So nope. Why water source is equals shared tab and visit dot time in queue is why is this in there? Let me comment this out. See, I shouldn't have brought another where. So how do we join this? And yeah, so please take notes. It says this the visit count must be one, and then any of those sources. So it means that and then any of those sources. Actually, to do a quick check, if we bring the time in queue here, just this is the time in queue, just to view that. Let's put a comma here, just to make sure we're on the right track. So all the time in queues here, even when we do it in descending order, good. Ascending order is starting from 30, so it means we are right. So let's just take that off. Our point has been proven. And then only wells that are contaminated are allowed. So we will exclude wells that are clean. We are going to exclude wells that the result is equal to clean. Remember,
Sam, before you go on, I think
yes.
instead of greater than or equal to 30, we just make it greater than 30 because it says more than 30 for the time in queue.
Mm, it says have queues times over than 30. Okay. Thanks very much for that. Greater than 30. Also meaning okay, actually the UN standard is supposed to be all right. So in any of the conditions, so only was contaminated. So where results should not be equal to clean. Mhm. And um, where was results well pollution. Yeah, dot results should not be equal to. And all of you, I hope you still remember your word cards. You remember your word cards. Just putting it here is cool for me. Yeah, so let's run this. And then we know why am I getting this? Or no, but it actually shouldn't contain, so it should be end. Is the end giving me this coming? I think now we should keep our visit dots. Yeah, time in queue just to look at something. I hate typing out this thing. And then let's put well pollution dots dot results also in. There's something wrong. We shouldn't
I
be
mean, you already
getting.
have results there.
Uh, okay, Charlie. But why is this query still giving me? We are querying from what us from. This is giving me 0, 0, 0, 0, 0. Why?
I think it's supposed to be all, but it still gives you clean index. So
Yes.
I don't know.
Yeah. These people they need to be in brackets. Let me remove the bracket and see.
Can I ask a question, please?
Yeah, I can ask.
Okay, so why isn't a word card for the clean? Because I mean, they are excluding words that are clean. So I thought it's supposed to be just clean. Or
Yeah, excluding. I think what you even just said made me realize this. I shouldn't even use the word card. So, man, why?
So I'm thinking that we have it's the where is equal to 1 and any of the 3. So instead of the
Any
and we use all for the 3 of them
for the three.
and put
Okay.
them in a bracket.
It says only and any of. Okay, so we can use or. So this or this or this or this or that. but we still have contaminated. All right, let's and include river and tap in broken home sources where water source equals. We should include or water source. Let me guess here. Type of water source. Equals what? Equals tapping hole broken. Include any river. Okay, equals river. And for here, I think I have to bracketize this one, parenthesize it, and just copy this whole query. Up in home broken, right? I'm a lazy typist, so pardon me, I don't like typing out a lot of things. You put that in our nice quotations and then our nice brackets here. Run this. You have a mistake. Water source dot type of water source e. Hey, Mitanka e will be stressing my bravo. My fast. Okay, but we're having some. You are seeing. Okay. All right, that's cool. So yeah, I think we are all set here. Those are the results. Some are giving contaminated vibes. So yeah, I think that's what we even need. Yeah, that's what we even need. Hmm. Okay, so after that, the clean ones are gone. Yeah. So Richard, the clean one, it means the clean that we were seeing, they were not for the well, oh, they were for the other
Yeah.
water sources. Yeah, so that was what confused us. So now they have a flow chart, which is telling us something. We are going to work on this in a jiffy. What's the time? Up today, we are not spending much time. Okay, we started at 9:30. It's now 11. So when we start, when we visit count should be equal to 1. And if it's 1, we will check with the well pollution. Is it clean? If it's clean, if it's not clean, then we go to the result set. And after here, we check source. Is it river or tap broken? Yes. Source type, it should be shared type? Yes. So if it's shared type, then the queue time should be greater or equal to 30 minutes. Madam, the one who said greater than 30 minutes, you've misled me. Almost equal to Mbrao. And then after that, we'll go to the result set. So actually here should be 30 minutes or greater. So I'll go and do that edit now. And then now the water pollutions, the improvement is that chemically contaminated, yes, then install in water RO filter. Is it biologically polluted? Yes, then we install UV and RO. Is the source If the source equals river, then we will drill wells. If the source equals share tap, we install X number of taps. If source equals tap in broken, diagnosis infrastructure. If nothing else, now rename the element. Note that I split up the logic into the where and case clauses. While this makes the logic more complex to follow, my thinking is to remove all of the data that we don't need first, like records with visit counts equals, then do calculations. So the data that we don't need, like the records with the visit counts greater than one, then we do calculations. What does Chidi mean by that? So you should remove all records where visit count is greater than one. Okay, I think we've already done that. Our visit counts are all equal to one. Yeah, so let's start with this. Let's start with where visits count equals one. This must always be true and any of the following. I think let me quickly check if our visit count equals one. Our visit counts. Well, yeah, so visit count is actually one. And then the rest must be true. Uh, clean, tapping, broken hole, and share tabs. Yeah, I think we've worked on that. Okay. Yeah, we've worked on all this. So we've worked on this query. Oh, so it means that we could have just come here, copy and paste, and then edited it. Now I'm a actually, I don't like suffering. I'm a soft guy. Fill in the blanks in the where filter and add it to the project process query. You should get 25,390 something and coins rows. Lo and behold, we are getting 15,000. And I think it's because of the greater than that we put there. Madam, yeah, we are over me. What are we supposed to do? There's something wrong. Let's look at their code well.
So I think
First, visit count.
after
Yeah.
it's supposed to be include starting
In.
home routine and then the river.
Mm, tap, it should be in. Tap in broken home.
And then
And
that
then it should,
river as
and
that's
then river.
yes.
Okay, yeah. So I made it to actually that was
No, that is it. But I am saying it should be in.
be in, yeah. Oh,
Yes.
suitability. Water source. Aha, yeah. And that means I have to clean all of this. So I have to clean them and then just use the in to separate them. I have to clean all of this. I think this code should also have worked. I have an error somewhere. What's my offense?
So the in after the in there should be what's the parenthesis?
Parenthesis. Yeah. So I have to close the other parenthesis. Okay, let's see if we get 25,000. Voila! On our way to progress table. So wells, let's start with wells. Depending on whether they are chemically contaminated or biologically contaminated, we will decide on the interventions. Use some control flow logic to create install UV filter or install arrow filter values in the improvement column where the results of the pollution tests were contaminated, biological and contaminated, chemical respectively. Think about the data you will need and which table to find it in. Use else now for find alternative. This is going to be interesting. So now I'm going to write case statements. Where do we write the case statements? Case statements in select statement. So it says, so it means we have to create a new column called improvement. Use some control flow logic to create values in there. Let's get to work. Let's see how we are going to deal with that. Good. So actually we don't need the time in queues, need them. And what else do we need? Yeah, let me put this since and case when let me indent this. Yeah, I should pardon my style of coding. Aquadron and missile. When the well pollution is contaminated, when is biological, when is let me take my time. So we use some control flow logic to install UV filter or install arrow values in improvement column where the results of the pollution test were contaminated. So when results equals contaminated, that's either biological or chemical, then we have to install either UV or arrow. All right. So UV filter is for biological and contaminated, and RO filter is for chemically contaminated. It means that still we need our results table. Our results table is here. So when well the pollution dot, so let me write this one. Well pollution dot results. It's like you can here we can use it's like, or you can use the contaminated biological directly. Let me put this is this one here. Paste and close. So when the well pollution results is equal to
Sam,
this. Yes,
why why
please.
why don't we use the like since I'm looking at the contaminated biological. Okay,
Yeah,
that's
that's
fine.
what I'm saying. That you can use the like if maybe you are not really sure about the
It's
spellings or
fine.
something.
Oh,
But if
sure.
you said
No, it's fine. So I was looking at the contaminated beneath what you just selected, and it was capital C. But I realized that is chemical. So that's fine.
okay, all right. So if you want to use the word cards too, it's fine. That's fine. This is also fine. Then install good. Install. Let me bring my quotation. So let's do this. Well, if it's biologically contaminated, then install UV filter. Let me copy this. Install this and once and we proceed. When this year is equal to chemical here. Then install this one also. Close it. Fine. So I'm done with the well. Now you go to reverse. Now for the rivers, we upgrade those by drilling wells nearby. So add drill well to the improvements column for all river sources. So where the water type source equals river, then drill well. Let me copy my drill down before I come back to this.
Why you know the light stress like that?
I know they like stress. Trust me. Copy and paste here me there. Let's go to water source column and let's see what we can do there. Where's my water source column? All right. So when water source dot type of water source equals river, and nicely pasted. We have to put drill over there. And let's go to our next condition. That for reverse. So now we are on shared tabs. So next up, shared tabs. We need to install one tab near each shared tab for every 30 minutes of queue time. This is my logic. When type of water source equals shared tab, and then we concat install this floor here, it says it's going to what are we supposed to, we need to install one tab near each shared tab for every 30 minutes of queue time. So we install the number of the time queue time here. We floor it first. Let's take this and go and paste it, and let's think about how to edit it later on. Let me copy it to the now value. Paste. Now we need to just specify this. So let's pull in our water source from here. If our water source equals shared tab, shared tab, and if our water is shared tab, we need to install one tab near it. So I want to know what shared tab and what time in queue, or yeah, and time in queue. What did I do here? I'm using floor here because I want to round the calculation down. Say the queue time is 45 minutes. The result is 45 divided by 30 equals 1.5, which could round up to 2. We only want to install a second tab if the queue is greater than 60 minutes. If the queue is greater than 60 minutes. So if here, let's take a look at the logic. Well, if the time in queue is 30 minutes, we are installing one tab. If it's 45 minutes, we are installing one. If it's 50 minutes, we are installing one. Unless it's 60 minutes, then we are installing two. Yes, it's using flow will run everything good. So if it's below 60 minutes, the floor, I think we considered this earlier on, later earlier in the models. Floor means you are rounding, but you are not rounding up, but you are rather rounding down. Because when you use round, 45 will be viewed as 46 and 59 will be viewed as 60. But we don't want that. We want it to, if it's less than 60, then it should come down. So 59 will be viewed as 50 and it's less than 60. So we install still one tab. That's what the floor is doing here. So we need to install one tab near each shared tab for every 30 minutes of queue time. This is my logic. And then water type source equals shared tab, and then time in queue. Time in queue should be, I have some time in queue somewhere here. No, I don't think we do. We don't have that here. And then uh, visit dot time q is greater. Is it greater? A. Time in q is what could I write? I don't know if you could now. I'm sure you know. Let me see. All my codes are gone. And then if water source type not water source equals shared tap, and then visit dot time in queue should we say greater than 30 minutes? Or no equals no, I think I'm sure I made mistake. Let me just
I mean,
import my code.
like, the visit and time in queue is a table and a column, but you've put them in, kind of say, quote. So you just need to remove the quote.
Come again.
You need to just remove the quotation from the visit and time in queue. Yeah,
Okay, so time in queue should okay.
greater than or equal to 30.
Yeah, I think I've seen what I did. Time in queue should be greater than 30. Yeah. Should, yeah, should be greater than 30. I forgot something that I did myself. The greater should be yeah, greater or equal to greater or equal to 30. And we're going to concat. What are you going to concat? Think here. The time in queue, we divide it by 30. Divide it. Let me just copy this thing. Divided 30. So it means that it will produce if this is the case, then it will produce install this thing here, the time in queue divided by 30, or install that number of tabs in these tabs nearby. Good. So let's see else now. And then we end as improvements. More room for improvements. I think I've missed. Yeah, yeah. So how is our code looking? Please, is anyone having any complications? Let me run this quickly and see if it will work.
So please, why are you ending as improvement?
Good. So to end as improvement means that now we've ended the query. If we remove this improvement here, we are not going to get a name for our table. Let me run this to show you something. We are not going to get our TK by mistake. So we see the name here. So as part of this query, we just have to end any case statement there. You have to end it with an end. So bringing the as improvement means that we are renaming the column here to read end as to read improvement. Please, are you okay?
Yes, please. Thank you.
as improvement. So just to name it, I think our code came out nicely. Now let's see what's next. Yeah, basically that we use this code and fill in the blanks to update the improvement column for our shared tabs with long queues. Check to make sure you are getting installed X. Okay, we still have something here waiting for us. Fill in the blanks to update the improvement columns for shared tabs with long queue times. Check to make sure you are getting installed X types of. So let's go and check. Here, those that are so we see good. Let's I wish we could filter this to look at only the shared tabs to see how they are reading. Anyway, it doesn't matter. Let's just look at them. So we see what we did now. It is reading install 8 tabs in broken home. I don't know, but what's the concatenation that we did here? It will calculate this thing here and then put the answer that it will get here inside this. So we've seen install 8 tabs, and then I hope to see something else. Install 1 tab. Yeah, I think that's what we were looking for. So that's what it means here, that check to make sure you are getting install X number of tabs value in the improvement column. So in home tabs, let's look at in home tabs, specifically broken ones. These tabs indicate broken infrastructure. So these need to be inspected by our engineers. So add a case statement to our query updating broken tabs to diagnose local infrastructure. Okay. So tap in home broken. So our final query will now return 25,000 rows of blah 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 shared tabs and broken tabs flagged for improvements. And so let's go and work on our broken tabs. When so water type dot water source was if it equals to, let me look at here, tap in broken home. Yeah, that's the person I was looking for. Then we should do what? Diagnose local infrastructure. So as usual, maybe, yeah. So let's run our query again and see. So we are diagnosing local infrastructure for the tap in broken hole. All right. So let's go to me and let's okay. We are having 25 kilos, so that's fine. Add the data to project progress. Now that we have the data, we want to provide to engineers populate the progress table with the result of our query. Hint: make sure the columns in the query line up with the columns in project progress. If you make any mistake, just use job table, progress, and run your query again. Good. So now the table that we created earlier on, I hope you guys remember the project progress. Now we have to populate that table with the values or with the columns that we have now. is someone willing to share with me how he or she will populate that table with the values we have here, with this thing here? Anyone has an idea what will do to him, populate that progress table? I have one part of it I'll give to that person, except Richard.
So, Green. Hello.
Yes, please, I'm listening.
Yes,
Bits and
sorry.
K.
I'm just asking something. I've typed the code up to
Oh,
where
okay.
we've reached, but when I try to run the code, it says that the unknown table location in field list.
Unknown table location. You
Yeah.
added the location. You just added the location. You look inside your select statement where you are selecting the location.
Mm-hmm.
Check if something is attached. Location dot what? Just
Uh,
location.
yes.
Then delete that column because we don't have just raw location like that. It should be location dot something. So delete
Yeah.
the location.
All allocation dot something.
And so delete the location that is in the select statement here.
No,
Yeah.
did he pick, is he working from that location table? So you should check the from statement to see if you have location reference there. I think that hasn't been referenced. So David, please check your from after your from or even any of the joining tables to see if you have location in there.
Yeah, I think the inner join location on.
Sam, scroll your screen down a bit, please.
Here.
So do you have it
Uh
in your inner join?
join
Yes.
location.
Yeah,
Location
I
dot
have that.
location.
Then check your spelling. Probably maybe spelling mistake.
Okay, I'll check it out.
Oh, so no one wants the Aliwa. Okay. So with that, how?
Wait, hi, please. I have a question too.
Okay.
Sorry. So I saw in the project that you're not supposed to have some null values there, but I'm having some in mind. I don't know if you also have some in yours.
No,
So
no.
yes,
Where we're not supposed to have now values.
that's what they were saying.
Which part? Which part of the slide?
Okay, so wait, I think 36. I don't know if you have 36 yet, but yeah, 36.
36. Yes. So okay. With no now. So our final query should now return blah 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 with reverse, various walls, share tabs, and improvements. And importantly, no null values. Okay, let's see if we have null values. We have null values for
No,
no. This is the results table.
No, no.
It means
So
the improvement table. Is it?
yes, so the improvement table. That's what I'm talking
Mm,
about.
you are having null values.
Yeah,
It
it's not
means
plenty,
that
but okay.
it means
Kindly
that
scroll down
when we
yours and
go
let me
at
see.
yeah, you are missing one of these things there. That's why. Try and look at it. Have a look at it.
Okay,
You
but
are
can you
missing one of
kindly
them.
like scroll down through yours and let me see something?
To where? Let me go down.
And just be there, just scroll. No, the improvement side. So the table.
Oh,
no. So he's talking about the
yeah.
table you just created, the table itself.
The table itself.
Yes.
Mm-hmm.
I should be scrolling down.
Yes, please. I just want to check.
Whether there is some null value.
Yes, because I did
Uh,
it. I literally did the same things. I'm just checking to see.
where okay, look at where the
Okay,
null
that
value
means
is. Look at where the null value is, and then match it to the type of water source which is giving you now. Let me see
okay.
something.
All right. Let me check that quick. Okay, that was shared tab.
So it means that you didn't write your shared tab uh, query wall, this query right here.
Okay, let me check that again.
Write it for.
Yes, please. Okay, thank you.
All right. So to populate a table, we have a table called project progress. So we are going to insert into project pro- progress. So what are we going to? You know that project progress has a list of columns, and we want to populate these columns. Which of these columns are we trying to populate? Let's check here. It says yeah, it was somewhere, so that somewhere, yeah, so that somewhere, yeah. Let me go up and go check. I'm just to make reference to this one. Somewhere here. How am I not seeing this? Okay, yeah. So the address, the town name, the province, the source ID, the type of water source, and the well pollution. This is what we want to be including in our project progress. Address, town name. So let me first type that address. I think province is also part. Province. Let's look at how they were named in the project process table. Okay. So address, town, province, source type, improvements. All right. Province. Should I see source ID? And then yeah, we have one, two, three, four, and I think improvements. Improvements. I think they should be okay. Is it I grab address here, town, province, source ID. No, so you need source type. You need source type, just like we have, yeah, source type. Let me fix that side here. Source type. So we are going to have one, two, three, four, five, six columns. Six columns. And you have to make sure that what we are aligning, it goes with this. So address, town name, province. Address, so this province. Address, province, and then source ID. So source ID before we come to water source type, and then so we won't be needing the results here. Won't be needing the results. It was just to filter, so we don't need this because we only needed it to filter our well pollution. That's all. Good. So we have one, two, three, four, five, six. So when we come here, we have address, town name, three, four, five, six. So we are going to copy all of this query Zuguma like that. Because we know that when we run this query right here, it's going to produce these 6 columns, just like we are having here. So if we select this and insert all everything into the project progress table, we are going to have the same results populated in there. As simple as ABCD. So let's copy and paste. Let's just go through to make sure we don't have any red cross down our necks. All right, it looks good. Okay, my channel. Insert into select. Yeah. So let's run this query and see where our fate lies. Unknown improvements. Okay, so apparently I made a mistake in the spelling. That's why I like copy and paste. Copy and paste. You don't get spelling mistake. That.
It's a
All
capital
right.
I.
You said come again.
It's a capital I.
Oh, it don't really matter. So we have 25,000 records, no duplicates, no nothing. So now let's refresh here. Hey, you know that I did a mistake. I was supposed to do it in the project progress copy here. Copy.
Asomaba.
Wow. I'm coming. Let me see. Wow. Okay, let me just refresh this again and see something. If my already made this thing skipped me very fast. So I think I have projects progress here. Let me see.
I think that is the
And it is giving me 50,000, meaning it has doubled what
ticket.
I did. Yeah, it has doubled what I did. I don't know if I can undo that thing.
So I think what you can do is you can drop your original progress project, and then
Yes.
the one that we just did, the copy, you can make
Mm,
that one actual copy and then you change the name.
okay, so let me drop the first this one that I have. Let me see. Can you even drop it from here?
Yeah, so
Yeah, drop now. Wow. Easy shortcuts were all the best. So let's select this and see. We are not seeing anything. Okay, it looks empty. So let's change this to copy. What's the name here? Paste. And let's run this. Okay, so let's view this one again. Let's rerun this code. Voila. So now we are having everything here. So the project ID has automatically populated because it has been set to not now. And then I think it will increase on its own. So I think the serial that was put there will make it increase on its own, I guess. And then the source status is backlog, date of completion. So this one will be reserved for the engineers. When they are done, they'll fill the date of completion and then they'll give their comments. So this form, I think this table can be printed out for the engineers now successfully. All right, so I think that's all for today. Yep, yep. Wait. Please, is anyone having any challenge or anyone doesn't understand anything? Person,
Okay, I have a
the
question.
person. Yes, please.
Okay, so I didn't join really early, so the copy bit I didn't understand that part. Like the projects then copy.
Yes, because I had already done this project on my own, I named that one the project progress. So
Oh
just
right.
yeah, so I just made this one copy so that it won't go and populate the other one. I still
Oh,
did it
okay.
anyway and I've dropped it. So
Okay, so I can just go ahead with mine without doing the
yes,
copy.
yes, yes,
Okay.
yes.
Okay. Thank you.
So yeah, you're welcome. So I think Didi has some final word for us. Please, who